Good day, viewers. You are welcome to Understanding Chemistry channel. On today's topic, we'll be learning on how to calculate the percentage composition of each element that's present in a compound. Okay, let's look at what we have today. The percentage composition of each element in a compound can be determined by, first of all, you calculate the relative atomic mass of that compound that's given to you. Then the next one is what? You calculate the mass in percentage of the element you are asked to find. And at the end, your answer will be in what? In percent. So which is the unit of what? Percent. Okay, percentage composition of the element you are asked to calculate is equal to what? Relative atomic mass of that element over relative molecular mass of the compound times 100. It's a simple calculation. Okay, let's look at this exercise. Calculate the percentage composition of each element present in magnesium triazonitrate 5. So like I said, the first step is what? You calculate the relative molecular mass of this compound. So the next one, the relative of each element, magnesium, the one of magnesium, divided by what? Relative molecular mass of the compound times 100. At the end, when you have done the one for magnesium, you have done for nitrogen, not for oxygen. They will sum up to what? 100. So you want to calculate the relative, you want to calculate the percentage composition by mass of each of the elements that are present in this compound. Magnesium, nitrogen, and oxygen. So here is what? Relative atomic mass of the elements that are present. So you're going to first of all, the first step is what? Find the relative molecular mass of the compound. So that's what I want to find now. Okay. Relative atomic mass of magnesium is 24. So relative molecular mass of magnesium is what? 24 times how many atoms do I have here? I have 1 atom of magnesium. What is in this bracket? These 2 multiplies only what is inside this bracket and not the one outside. So I have 1 atom of magnesium plus 2 times 1 for nitrogen, 2 atoms of nitrogen. So what's the relative molecular mass of nitrogen is 14. 14 times 2 atoms of what? Nitrogen plus the relative molecular mass of oxygen is 16 times 2 times 3. So I have 6 atoms of oxygen. 24 times 1 is 24. 14 times 2 is what? 28. Plus 16 times 6 is what? 96. 148. 148 is the relative molecular mass of this compound, which is going to help us to calculate the percentage composition of each element present. Formula: percentage composition of elements is equals to what? Relative atomic mass of the element divided by what? Relative molecular mass of the compound times 100. So look at this. Then we're looking for the what? Percentage of what? Magnesium. Percentage by mass of magnesium. So it's now the what? What's the mass of what's the relative atomic mass of magnesium? It's 24. What is the relative molecular mass of that compound? Of this compound is 140. So 148 is what we got. 148. So divided by 148 times 100. 16.2. Put your unit percent. So let's look at that's presented by mass of magnesium in magnesium 5 is what? 16.2%. So magnesium contributes only 16.2% in this compound. So let's look at the one for what? Nitrogen. Percentage by mass of nitrogen is equal to what? Here I have 2 atoms of nitrogen. And the relative atomic mass of nitrogen is 24. So 24 times 2 divided by what? The relative molecular mass of the compound, which is 148, times 100, which is what? 28. 24 times 2 is 28. 148 times 100. So by the time you do this thing, 28 over 148 times 100, I'll be having what? 18. Let's look at what to have to confirm what we did if it's correct. So the one of magnesium we got, I want it to be what? 16.2. Nitrogen 18.9. Oxygen 64.9. So let's add them up. So 16.2 plus 18.9 plus 64.9. So total 100. So it means that what we did is what? Correct. So like I said, the other method, if you don't want to do this one, if you want to find the percentage of the third element, the last element, you do 100 minus sum of the what? Percentage of the others. So percentage by mass of oxygen. So it's equals to 100 minus percentage by mass of magnesium plus nitrogen. So it will now be what? 100 minus 16.2 plus 18.9. 16.2 plus 18.9, I have 35.1. So 100 minus 35.1, 64.9%. So you can see we got the same thing. The same thing gave us the same thing. So you know the method I want to use, you are correct. Let's look at the last exercise. Calculate the percentage of water of crystallization in this compound. Sodium triazocarbonate 4 decahydrate. So water crystallization, this is the water crystallization. So this compound has what? 10 molecules of what? Water of crystallization. So like I said, the first step is what? Calculate the relative molecular mass of the compound. So let's look at calculate the relative molecular mass of the compound. So relative molecular mass of is equals to, okay, let's look at this. So I have 2 atoms of sodium and the relative molecular mass of sodium is 23. So 23 times 2 plus 1 atom of carbon, relative atomic mass of carbon is 12. 12 times 1 plus, I have 3 atoms of oxygen, the first oxygen, 3 atoms of oxygen. 3 times, oxygen is 16, 16 times 3 plus 10 times 2 is what? 20 for hydrogen. And the relative atomic mass of hydrogen is what? 1. 1 times 20 plus 10 times 1 for the oxygen in water is what? 10. Relative atomic mass of oxygen is what? 16. So plus 16 times 10. Let's sum them together. 23 times 2 is what? 46. 46 plus 2, 12 times 1 is 12. 16 times 3 is what? 48. 1 times 20 is what? 20. Plus 16 times 10 is what? 160. So I'm going to sum them together. 86. 286. So relative atomic molecular mass of this compound is what? 286. So the second step is what? Calculate what? The percentage of water crystallization. We are not asked. The first one I did, we calculated what? For the element present, each of the element present for sodium, carbon, oxygen. But this question in particular is what? Centered on what? Percentage of water of crystallization. So that's what only one I'm going to look at. So percentage by mass of water. Percentage by mass of water of crystallization is equals to. So I have so this is the formula. This is 10 molecules of what? Water divided by what over what? The relative molecular mass of the compound times 100. So 10, remember the relative molecular mass of water. When you do hydrogen, hydrogen is 2. I have 2 atoms of hydrogen. 2 times 1 is 2. Oxygen is 16. So water, the relative molecular mass of water is always what? 18. So without wasting time, we just do 18 times 10 or 10 times 18. Anyway, is correct. So 10 times 18 divided by what? What is the relative molecular mass of the compound we calculated? We got 286. So we got 286 divided by 286 times 100. So we'll be having 18, 10 times 18 is what? 180 over 286. Over 286 times 100, which is equals to what? 62.9%. So you can see the water crystallization has what? Higher percentage in this what? In this compound. So this is what I've got, 62.9%. We've come to the end of today's lesson. I hope you can, I believe I can calculate what? Percentage by mass of each element present in any compound. Or salt that has what? Water crystallization. You can remember to calculate the percentage of water crystallization in that salt. If you are new to this channel, you have seen this video for the first time, hit the word subscription button. Like this video and share it so that you can get to what? More people. Thanks for watching. Have a great day. Bye.